what happens in nature. And Da Vinci understood that a bird is interested in a flying machine, not be flying. Hooke and Newton. Hooke and Newton were always in conflicts, and this was the reason why Hooke was not very happy, and he tried to make investigations, and he tried to publish these investigations in such a manner that Newton cannot take these investigations as Newton's contributions to mechanics. And one of his, the idea was that the extension is so like the force. In that time, please remember, there was never ideas how to formulate stresses and strains. And so he makes this assumption that there's a proportional law between the extension and the force. You see here also this situation on the diagram. This is extension, this is a force. And so this is an original idea that is in a proportional interlink. And you see here a straight line as a main information from this screw or graph. Who published this thing very early in 1676 as an anagram. An anagram is a combination of all words, letters, in the alphabetical order. So if you look to the Latin sentence here, you see here the Latin sentence, ut tensio sic vis, combining the letters in the alphabetic order, you get the anagram, which is in the first line. In that time, 2 years was necessary to explain what Hooke mentioned, and only in 1678 it was published in Latin in the correct manner. What is interesting, the language of the science was also in that time unique, but it was not English, it was Latin. A last remark concerning the slide. You have here a portrait of Hooke, but this is not correct. You find in the Wikipedia this portrait, you find in other books this portrait, but it seems that Hooke never allowed to show his face on portraits or on pictures, and so it was another guy which was maybe similar to Hooke, but maybe not. Let's come to the new interpretation of the Hooke's law. It is again the relation in a linear manner between two properties, but now we are saying that it's better to use the stresses instead of the force and the strains instead of the elongations. Okay. What is interesting, if we are looking to Hooke's contributions, then we see immediately that there are relations also to practice, because we have a so-called rheological model immediately established, and the rheological model in this case is a spring. What is interesting, if you are looking to the spring law, this is also a direct proportional law for the force related to the displacement. And there is a parameter K. The sign is because the force is opposite to the motion. And if you are looking to the modern form of the Hooke's law, it's very similar. Our Young's modulus in this case is minus K. Minus we forget for a moment, but K and E are different. E is a pure material property. So by the Young's modulus, we are expressing a property of the elastic behavior of a material. If we are looking to K, this is interesting, but we have to mention that K is depending not only on the material properties, but also on the size of the spring and on the other effects. Size, that means not only the length, this means not only the thickness, but also the shape of the springs and so on and so on. So this K is a complex parameter, not only related to the material properties. But truly speaking, this is a rheological model and an analogy between the elastic behavior and the behavior of a spring. Coming now to Bernoulli, again a mathematician.